Studio Sheet 9, question. Okay, we'll start from question 9. So find the points on the graph. Y is equal to 1/3 x to the power 3 plus x squared minus x minus 1 with the slope. I mean, when the slope is a -1, b 2, and c 0. So when you're given the slope, your target was the equation of the line the equation of the gradient, which gives us a slope. The gradient is the slope, so the equation which gives the slope is the first derivative. So our target is to differentiate this. When you differentiate, we'll get 1/3 multiplied by 3x to the power 2 plus 2x minus 1, simplified as x squared plus 2x minus 1. Okay, so since the slope is given, we equate this first derivative, which is the slope equation, the gradient equation. We equate it to, in the case of A, the slope is given as -1. So we have x squared plus 2x minus 1 is equal to -1. If we take this number the other side, we'll have x squared plus 2x is equal to 0. So that x plus 2 is equal to 0. So x is 0 or x is -2. So these are the values of x at which the slope of the line that passes through these points is -1. Now the question is asking for the points. A point is x, y. So you get the value x. So you're saying points. We have 0, we look for the y coordinate, and we have -2, we look for the y coordinate. So get 0 and take it in the original function. So what is y of 0? That is -1, because we have 0 to the power 3, 0 to the power 2, minus 0, giving us -1. What is y -2? So we substitute. When there is x, we take -2 to the power 3 plus -2 squared minus -2 minus 1, giving us -8/3 plus 4 plus 2 minus 1. This is 4 plus 2, 6 minus 1, 5. So I'm doing it -8/3 plus 5/1. Get the common denominator 3. Then we have -8 plus 3/5, 15. 15 minus 8, we get 7. 7/3. So we have 7/3 there. So those are the points at which the slope to this equation is going to be -1. If we go to B, the slope, let's check for the slope in B. The slope in B is going to be 2, meaning get the same equation and equate it to the slope. So I have to find x, and then you go to the original equation and substitute x for you to get the points. So this is going to be x squared plus 2x minus 3 is equal to 0. This is a quadratic. So you have x squared minus x plus 3x minus 3 is 0. So x minus 1 plus 3 x minus 1 is 0. So x is 1, x is negative 3. Take 1 in the original equation. What is y of 1? That is 1 over 3 plus 1 minus 1 minus 1. So we're dealing with 1 over 3 minus 1, which is negative 2 over 3. Hello.
Why didn't you differentiate for B?
No, we're using the already differentiated equation. This one here. So only differentiate once, and then it's the same derivative, just changing the slopes. Does it make sense?
Yes, sir.
Okay. So we have a point 1 comma negative 2 over 3, and the other one you're substituting negative 3 in the original equation. So we have y over negative 3 is equal to negative 3 to the power 3 over 3 plus negative 3 squared minus negative 3 minus 1, which is equal to negative 9 plus 9 plus 3 minus 1. So that's 0 there. And then 3 minus 1, 2. So you get another point, negative 3 comma 2. And for C, we use a different color here. Blue. For C, the same gradient equation. This time around, we are told the gradient is going to be 0. So, is there an easy way of solving for x when the gradient is 0 here? No factors. So you can use the formula. X is equal to negative 2 plus or minus the square root of 4 minus, which is going to be plus 4 over 2. So we get negative 2 plus or minus root 8, which is the same as 2 root 2 over 2, so that we get negative 2. I mean, we can divide through the 2, so we'll have negative 1 plus or minus root 2.
Sir,
Hello.
I get what we're doing, but I don't understand why we're doing what we're doing. Like, how is the situation? What is it really? I don't understand why we're doing what we're doing, but I know what you're doing, but I just don't know why.
Sounds like it sounds like a poem. Look, since you know what you're doing, but you can't understand why, let me give you the reason. When you get the gradient, I mean, for you to get the gradient, if you are given f, what do? If you are given f at x is equal to c, you are looking for the gradient. What do? You differentiate f. After you differentiate f, you come and substitute c, that value of x. What you get is called the gradient of a tangent line. Meaning, if you are given the gradient and you don't have the value c, you get your gradient, keep it somewhere, go to the function, differentiate it, and instead of you to substituting c, which you don't have, you equate the derivative to what you have so that you're able to get c, which gives that slope. And if you have that c, then this c is the x coordinate of a point where that line touches the curve f of x. So when you get this x coordinate, for you to form a point, you will need the y coordinate. So you use this c in the original f to get the y coordinate so that you have a full point. How does this sound?
Oh, no, I understand, sir. I understand.
Okay. So that you now have the task to get these points. These are the x coordinates. Use them in the original function. They're not good though, but use them there to find the y coordinates so that you don't spend all our time solving question 9. Hello.
So do you put the negative and the positive?
Yes, because there are two values, just like we used +1 and -3, just like we used 0 and -2. So you also use the -1 plus √2 and the -1 minus √2. Question 10, sketch the graph of f of x. Sketch the graph of f of x is equal to 4 minus the absolute value of x minus 2. After you sketch it, is it continuous when x is 2? So let's test the sketch. How do you sketch these graphs? We sketch them in a very, very easy way. We said you go inside the modulus. Okay, there are two ways. If you want, you redefine that function. Maybe let us use the redefining one. We say f of x is equal to 4 minus x minus 2 when x minus 2 is greater or equal to 0, negative x minus 2 when x minus 2 is less than 0. So we have 4 minus, so now I'm putting it here, 4 minus x, 4 minus x minus 2 when x is greater or equal to 2, and 4 minus negative x minus 2 when x is less than 2. Now here we have 4 minus x plus 2 when x is greater or equal to 2. We also have 4 plus x minus 2 when x is less than 2. What does this mean? 4 plus 2, 6 minus x when x is greater or equal to 2. And 4 minus 2, we get 2 plus x when x is less than 2. So to sketch this function, we'll sketch the piecewise. So we're starting at 2. So when 2 is greater or equal to, when x is greater or equal to 2, you first get your 2, look for f of 2. In the function where it is included, you have 6 minus 2, which is 4. So we have a point 4. You put a closed point there because 2 is included. Pick a number that is bigger than 2 to get the direction of this. So you're going to have 6 minus 3, which is equal to 3. Just telling you that this guy is going to come down. So you graph it this side in this way. Of course, you may wish to get this coordinate. You may wish to get that coordinate there, which is easy. You just say 6 minus x is equal to 0. So x is equal to 6. So this is 6. Then you go to your left. What happens when x is 0 in this function? We're going to have 2 plus 0, which is 2, meaning that on the left, this guy coming this way. So it has crossed at 2. So you can get this one also by equating 2 plus x to 0. So x is negative 2. The sketch is well sketched. So we have it here. There are so many ways of sketching this. If you want, you would have just gotten x minus 2 equated to 0 and get x is equal to 2. Then you know 2 is going to give you the starting point. Substitute 2 in the original function. You have f of 2. You get 4. You get 4 minus 2 minus 2, giving us 4. So you know you have 2, 4. That's where you're starting. Then you look for a y coordinate. And then you have the left line. And then on the right, since the gradient, or since by that time you haven't gotten it in this form, on the right you pick a point like we picked and check until you get the intercept. Okay, so that is the sketch. Let us now answer the question of continuity.
I'm behind the graphing part.
What's the problem with the graphing part?
Like those points, -2 and 6, like how you got them and why the midpoint was 2.
After we redefined our function, we got 6 minus x. We got the function f. What we are saying now is that f of x has been redefined to this form. This is f of x. Okay. So why is it f of x? We just redefined this guy here using the definition of the modulus function. So you have 6 minus x when what? When x is greater or equal to 2. So we're talking about 2. So we'll go to 2, substitute it in this piece, we get 4. The 4 we get forms the closed point with 2 because 2 is included in this interval. X is greater or equal to 2. When you come to this interval here, if you substitute 2 here, you get 4. So you do nothing on that closed point. Just know that it's also starting from there. Okay? Then how do I get the intercept on the right and on the left for x? You equate each piece to 0. So 6 minus x is equal to 0 will give us x is 6. So we have 6, the intercept for x on the right. Then 2 plus x is equal to 0. We'll get x is equal to -2. The intercept on the left. From there, you want to know the y-intercept. The y-intercept is an easy thing to know. In each function, the y-intercept is when x is 0. So you can't bring in 0 here because this is only defined when x is greater or equal to 2. And 0 is less than 2. So bring 0 here. So we have 2. So that's why we're having this scale. having that structure there. Now, to check if the function is continuous, this is our first question on continuity. So you must take our time and be slow in understanding. 1, if the function is continuous, then you require that if f of x is continuous at a point x is equal to c, then 1, f of c must be defined. 2, the limit as x goes to c of f of x must exist. 3, the limit which exists as x goes to c of f of x should be the same as the value of f you got when you substituted c in part 1. In other words, you are saying part 1 and part b should give you the same solution. So for our question, we are looking for continuity at x is equal to 2. And for a limit to exist, we demand that the limit as x goes to c from left of f should be the same as the limit as x goes to c from right of x. Then you will say the limit exists. So when x is 2, the first condition is asking us to look for f of 2. Is f of 2 a number? Okay, is f of 2 defined? So let's go and check. F of 2, you can substitute f of 2 in this one or in the original one. Now, since 2 is included in 6 minus x, f of 2 is going to be 6 minus 2, which is equal to 4. 4 is defined. We go to part 2, condition number 2. We want a limit as x goes to 2. Now for piecewise functions, you use direction limits, you use side limits. So you start with the limit as x goes to 2 from left of f of x. Okay, this will be the limit as x goes to 2 from left. Which function here, from the graph as you can see, which function approaches 2 from left? It's this line here. This line, the value of x goes to 2 using this line. So as x goes to 2, we'll be using this function here. Now this function is 2 plus x, meaning for us to find this value, we'll use 2 plus x, and the limit of such functions, you substitute. The negative does not become part of x. The negative just shows us the direction. So you substitute 2 plus 2, we'll get 4. This is the left limit. Then we also check for the limit as x goes to 2 from right of f of x. This will mean we're looking for the limit as x goes to 2 from right of which function approaches from right? Of course, it's 6 minus x. So we have 6 minus x, which is equal to 6 minus 2, which is 4. Now, when the left and right limits are equal, you say that the limit as x goes to 2 of f of x is equal to 4. And then you go to part 3. Part 3, we just check if what we got in part 1 is equal to what we got in part 2. So here we have the limit as x goes to 2 of f of x is equal to 4, which is the same as f of 2. Hence, f of x is continuous at x is equal to 2. That's how you check continuity, and that's how you conclude. Is there any question here? Okay, so we still have some 7 minutes. We can do question 11. The cross section of a 5-meter trough is an isosceles trapezoid with a 2-meter lower base, a 3-meter upper base, and an altitude of 2 meters. Now the trapezoid isosceles trapezoid with a 2-meter lower base. So you're talking about something like this. You have a trapezoid here. You have a trapezoid here with the upper base is 3. And then it has some length going to another trapezoid cover. You can do this. That's a trapezoid cover. So we have, and this guy here going there. And then this one is going that far end with this guy coming here. Okay, now this is 5 meter long, and then when it's 5 meter long, the upper base, let me label it in a different color. So this is 5 meter long, and then the upper base is 3, the lower base is 2 with an altitude 2. Now, water is running into the trough at a rate of 1 cubic meter per minute. So we are talking about volume, but volume of this thing is the area of this trapezoid base multiplied by the length. The area of a trapezoid base is half h base 1 plus base 2 multiplied by L. But in this case, water has risen to some level. Water is running into the trough at 1 meter, at a rate of 1 cubic meter per minute. How fast is the water level rising when the water level is 1 meter deep? So water is somewhere there, okay, 1 meter deep. So if you have 1 meter deep water, That is the height inside. Okay, that's the height inside. So we need to get that base where water is. Remember, one of the base is the same as the height, which is the altitude. So we have half h. So one of the base here, B1 and B2, is the same as h, but the other one is the upper base of the water level. Now we use this relationship of the triangle for you to get this one. If that is a B and this is A, how do we get the middle one there? In the proportion triangles, you get that this here is B over A. What B over A? Height. Okay. Or in other words, from the proportion triangles, to avoid the thing about all those terms, what you'll be doing is that you would always go, because they always give you this to be the same as the altitude. So you just get 3 for the upper base over the altitude, and then you're multiplying by the h. That is the reason for the water. So that you multiply by L, but L has been given as 5. So 5 times half, we'll get 5 over 2. And then inside here, we have h plus 3 over 2h, which is 2h plus 3h, giving us 5h over 2. Now 5h over 2 times h, we'll get 5h squared over 2, which is equal to 25h squared over 4. Then when we differentiate volume with respect to time, it means that we differentiate volume with respect to h, and then h with respect to time. But volume with respect to time will be 50h over 4, and then h with respect to time, we don't know. But we are given the rate at which volume is changing, that is 1 meter cubed, when h is 1 over 4 or dh dt. So the rate at which height is changing when the water level is 1 meter deep is going to be 4 over 50 meters per minute. This can be simplified as 2 over 25 meters per minute. So once